everyone, my name is José. I'm a Principal Data Analytics Consultant at Adatis, and today I'll be talking about the Common Data Model. At the end of this session, you should have a good understanding of what is a Common Data Model, why it should be used, and most importantly, how to use it. So get yourself comfortable and let's deep dive into the Common Data Model. Before we jump in the session, just a few more details about me and where you can find me on Twitter. So if you search for me on Twitter using the Z Miguel Mendes handle, and you can also see some of my blogs in the address adatis.co.uk/author/José. You can also go and check lots of other interesting blogs written by my colleagues at Adatis. So, what can we expect from the session today? We will start with the basics. We will understand what is the Common Data Model and how we can use it. But most importantly, we will understand why we need to use the Common Data Model and what are the type of problems that it can solve. After we are done with that, I will start demoing how to use the Common Data Model using the Power Platform services and the Azure Data Services. So, before we jump and understand what is the Common Data Model, first we need to understand why we need such thing. Now, if we consider that in many companies, we have many different applications. We have an application for timekeeping, for HR management, for payroll, and for financials. Those are the most common applications that each company will have. Each of these applications will have their own databases. Let's assume that we are talking about the employee entity. An employee entity will be structured differently according to each different application. So within the timekeeping, we might only store details such as the name, the project that the consultant is allocated. But then within the HR management, we will have more details such as the enrollment date, the position, and all sort of HR information. Now, let's assume the following. Let's assume that we want to sync the employee information across the different applications. This is a very complex data integration project. Why it is? Because the application from timekeeping will have to access the data from the HR management, payroll, and financials, and the HR management will have to access all the others, and so on and so on. And so if we look how this project would look like, we are expecting something like this. Now, this is a very complex integration project, one that will give lots of headaches to an architect, but also to an InfoSec person, because we are accessing secure information from other applications that might not be proprietary from the company. So does that mean that this is an impossible problem to solve? Well, luckily, it is not. One much simpler approach will be the use of a shared data model. What we are saying here is that this shared data model would act as the single source of truth, and these applications would read and write from the same location, meaning that it will have a consistent information and structure. Now, we can still have other applications connecting to their own databases without having an impact. And if we need to, if such applications will then have such requirement, which is to access information from other applications, then we can simply expand our shared data model, and the development phase will be much simpler. So what is the CDM then? It is nothing more, nothing less than the shared data model that we saw in the previous scenario. It is a place where we ensure that we ensure the application integrity and consistency. It is a place to keep all our information that needs to be accessed by many different applications. In other words, and according to Microsoft, CDM is a structure that comprises entities, attributes, and relationships that represents business concepts. It is an extensible collection of data schemas published by Microsoft that are designed to make it easier for you to build, use, and analyze data. This collection of predefined schemas represents commonly used concepts and activities, such as employees or accounts, and simplify the creation, aggregation, and analysis of the data. Microsoft has fully adopted CDM starting with Dynamics 365 and is continuously expanding it through the collaboration with industries in other different sectors, such as the automotive and the healthcare. They are so committed that in fact, they currently have more than 250 business entity definitions available to use by anyone. So now that we know what is the common data model and why we should be using it, we need to understand how we can use it. Now, the common data model is available to use from and using from the services within the Power Platform, such as Power BI, Power Apps, or Dynamics 365, through to the Azure data services through the use of data factory Dataflows, or machine learning, or Databricks. What we have here is now the ability to use and access data that till now was in a closed environment, such as the data within the common data services, and take advantage to run advanced analytics and expand that data and take even more value from the information that we already own. But how is this information stored? We can see in this diagram that all these services are supported by the Data Lake Analytics Gen 2. All the information, all the metadata, and all the CDM folders are stored within ADLS Gen 2. So let's have a look at how it looks. We are all what I like to say in a transitioning period. Up till probably April this year, the way that the CDM folders were stored in the lake were using what is known as the model.json. And we still have services using this approach, such as Dynamics 365, Power Apps, and Power BI Dataflows. The structure is composed of files and folders. Every CDM folder contains two elements, a JSON file and data files. The model.json metadata file contains semantic information about entity records and attributes, and links to underlying data files. The data files are in CSV format and follow the CDM structure. In this version, only Excel CSV files is supported. The evolution of this model, now used by Data Factory Dataflows and some of the library that we will see later used by Databricks, is now known as the manifest. The manifest.cdm.json file contains information about the content of the CDM folder, the entities comprising the folder, the relationships and links to the underlying data files. The main difference to the model.json is the possibility to create multiple manifests stored in a single folder, providing the ability to scope data for different data consuming solutions. The cdm.json file contains a definition for each common data model entity and location of data files for each entity. By having each entity definition in an individual file, managing, navigating, and discover an entity metadata is much more easier and more intuitive. All of these will make much more sense in a few moments where I will show the content of these files. Okay, now that we are done with the basics, we understand what it is, how it can use, and how it looks, let's jump into our first demo of the day. Here I have a Power Apps application. This application is using the CDM contacts entity. What this application allows us is very simple. We can simply create new records, new contacts, delete and update those contacts. How can we leverage and how can this data be stored within the data lake? Again, very recently, came out of preview, we have a new functionality within Power Apps called Export to Data Lake. What this allows us is to, every time that we apply a CUD operation, a create, update, or delete a record within our app, we can get that data and those updates automatically within the data lake without having to do anything. All that we have to do is, at the first instance, setting this up, and then we are good to go. So the trick here is to make sure that the entity that we select is tracking the changes. So here I have a set of entities, and within each entity, if we create a new entity, for example, we can either, in this case, I use an existing CDM entity, but if we create a new entity, what we need to ensure is that this, in create and update settings, we enable the change tracking. Okay, so I come to the export to data lake, and I already set my previous connection to the data lake. Now there are two things that you need to be aware. First, that the ADLS needs to reside within the same AD tenant as the Power App. And second, that the data lake needs to reside within the same location of the Power App. So if we wanted to create a new data link, we could simply create a new link to data lake, select the storage account, and then select the entities. because I already have this, I will simply click on this one. Now I already created a contact. So I already synced my contact CDM within my lake. You can see that the last sync was on the 19th, and I have 13 rows. So if I want, I can simply do manage entities, select account, and save. What this will do is now it will sync this information and save it within my data lake. If we have a look at the data lake, we can see that it automatically creates a new storage account with a very friendly name, as we can see. And this is the content. We have a model.json. We have the trickle feed service that manage the updates of in the lake whenever there's a create, update, or delete operation. And then we have our contact details. Now, if we open our contact entity folder within the lake, we have one file that is partitioned by year, and this is something that you cannot control yet. It is controlled by Microsoft, and every time that there's an update, every hour there will be a new snapshot taken. So if I go back to my app, let's say I want to create a new user. Okay, let's save. By doing this, automatically, without doing anything, the export data lake will understand that there is an update and will, if I click on refresh here, we will see in a few seconds that we have 13 objects. Let me just quickly pop here and start the cluster. Okay. If I refresh again, now we can see that we have 14 records. And if we go to the data lake, notice that it says that's 1857. It has been updated. A snapshot has not been taken yet, but in the next hour, there will be a new snapshot. This is done to ensure that the applications that are already linked still have a consistent view of what they had before. We could, in this case, we just added a new record, but we could have added a new column. And because of that, if we had already some applications using, they will have that consistent view that with, for example, 10 columns, and then new applications that will connect will be able to see the next the new record already. If we look at this model.json, the model.json hasn't been updated yet, again, because it will only update it within the next hour. But if we come to the trickle feed service, we can see within the model.json snapshots that I have an update taken, snapshot taken every hour. And this is something that I don't have to manage, is something that is done automatically for me. So how does this model.json file looks like? I already have here the model.json, and as you can see, all that we have is a lot of metadata that is describing the entity that my customer entity. This model.json file will only point to the latest snapshot. It will never, you will, to be able to see the previous snapshots, you will have to look at this the snapshots that were taken from this model.json. So this model.json file that we see in the root folder, it's always containing and pointing to the most accurate data. And this is the common, this is how we can obtain and take the data from the CDS on Power Apps and store it in ADLS for further analytics. Now, the other option that we have, because here we are constrained by the ability of only being able to export the data to a specific region and to a specific lake, the other option that we have is the use of Power BI data flows. Now, if I come to Power BI, up until very recently, this was also limited to a single ADLS per tenant. What this means is that I will link my data flow storage to my data lake, and then I could no longer update that link and point to a different data lake. Now, fortunately, Microsoft has improved this. If we come to the definitions, admin portal, and we come to Azure connections, you can see that they are still in preview. We now have two options. We have the tenant level storage, which is still not letting, although it says disconnect from Azure, when I attempted it still did not let me disconnect from this resource group because no longer exists. And then we have this workspace level storage permissions, meaning that per each workspace, I can set my different ADLS. So when we create a new workspace, we can come to settings, Azure connections, and specify where we want this data flow data to be stored. Now, once again, this needs to be within the same region and within the same tenant, just like within Power Apps. So what can we do then? If I come to my workspace, data flows, and create data flow, I have a couple of options, but right now I'm interested in two different options. One is to define a new entity. The next is to attach an already existing common data model folder. Now, let's start with adding a new entity. As we come here, this time what I will do is I will want to extract data from my customer table within my SQL database. So I need to select Azure SQL database. Apply now. Azure SQL database. I pass my server. Let's come here. My database name. Next. I select my customer and select transform. This is where the trick lies. Within this transform, we will map this customer table and details to an existing CDM entity. To do that, we need to, once the data is loaded, we need to come to this CDM map to entity. What this allows us is to then to map each one of these columns to the already existing structure of the CDM entity. So I can search for contact, and I can do automap. By doing this, automatically it will attempt to match the by name. But in case they don't match, what you can also do is to come to this, select this drop down and say, I want to map account ID to customer. Now I won't go any further because of time, otherwise I could map each one of these manually. But if I click here, we can see that these are the already mapped columns based on the name, and these are the columns that will need to be mapped manually. I press OK, and then I will do save and close. When I do save and close, I will have to give a name to my data flow and either refresh now or set a refresh. Now, the main difference to the Power Apps Export to Data Lake service is that my updates are not, my data is not updated instantly in the data lake. It will only be updated according to a schedule. Save and close. It's going a bit slow today. But in the meanwhile, I already created something within the lake. So let's have a quick look at how it looks within the data lake. Again, because my Power Apps and my Power BI are in two different regions, I have to create a separate Power BI, a separate ADLS Gen 2. Automatically, not automatically, we need to create a blob container called Power BI, and we also need to make sure that the Power BI service and the right access is set not only at the container level, but also at IAM level. If you search within the internet, you will be able to identify exactly which permissions you need to set. But two of them are the Power BI for the data lake. The most important is the Power BI service. So once again, what we see here is a model.json and a customer, my entity, and then my snapshots. Now we can see here that I already have two snapshots. As differently to what we saw within the Power Apps, this snapshot is taken every time the data is refreshed. So because I refreshed my data flow twice, I could see that I had two snapshots. And then if I come to my customer, this is where my data is stored. So having a quick look, giving let's call it SQL Beats customer, save. I could have updated the name of my entity, but I left it as sales LT customer. And then if I do refresh now, my data will be refreshed. Now it's currently refreshing the data. And so if I now come to my CDM demo, data flows, I can see that now I have two separate data flows, the one that I created before and the one that was created just now. And we can see that is currently refreshing my data. Now, if I come to my data lake, now I can see that I have two folders, one for each data flow. Again, only one snapshot expected because we only refreshed once, and then my model.json and the data. Now, the other option that I have is to attach an existing CDM folder to my Power BI. So what I can do is simply come to create data flow, attach a common data model. You come to the lake. Let's come to this one. Come to the properties. Copy this URL. Give a name, external CDM. And there are a couple of things that you need to change. First, you want to change this blob to use DFS, and then you want to replace this %2f with the actual value. Create and attach. And you can see that now we have an extra CDM folder attached as a data flow with the external flag. You can see that you don't see a refresh here because this is not controlled by this data flow. Now, how can you then explore this data? We can come to Power BI and say that we want to connect to Power BI data flows. This is an existing connection already. CDM, data flows. I select my customer and load. As the data is loading, we can come here to SSMS, and we can see that we have, if this allows us, take some time, that we have 847 contacts. So let's wait for this to load. It's taking some time. And what I will show here is that as this is loading, I can create a new record. See, it's already loaded. Still loading. And as soon as I create a new record, I could simply come here to Dataflows customer, press refresh. And this will go to my database, pick the latest records. Power BI is being a bit slow. And If I will then click on refresh, I will be able to see the new record that was added to the database as expected. Now, this here is the old way. Let's say it's not the old way, but as you can see, it is using the version 1, which is the model.json. So what if now I wanted to actually have the ability to enhance my data within the CDM folders from other locations? Now we saw that within the Power Platform, our options, we are currently limited to having a data lake existing within the same AD tenant and also within the same region. But if I wanted to get that same information from a different location, then I will be limited unless we would use the Azure Data Services. So the first thing that I would like to show is how to use the Common Data Model within Azure Databricks. Just to demonstrate that it's true what I was saying, but let's say that is too much right now. It's being very slow. You could see this as this, which will show the number. But let's move to Databricks. Now, within Databricks, we have a very within Databricks, we don't have by default the ability to read and to write to the CDM. Now, if you are using Synapse, then you wouldn't have to do this. So if you are using Synapse notebooks to read and to write to the data lake, you wouldn't have to do any extra step because it is already installed by the library, is already installed by default. But within Databricks, we have to install a new library that allow us to read and write in the CDM format. So originally there was a library called Spark CDM only that hasn't been updated for a very long time, and to be honest, it was full of bugs and not really in a good state to be used. But recently, we can see that Microsoft created a new connector called Spark Cdm Connector that has been actively updated. Now, this is still on version 0.17 and it's not in a production state to be used. If you go through the GitHub page, you will see that, as you can see, is in early limited preview and may change without notice and is not recommended or supported for use in production applications. But it is very, very promising. So let's have a look. You can find the library within Maven. All that you have to do is spark.cdm and then you install. One thing to be aware is that this is still not supported within Spark 3.0, so you need to install within the previous version of Spark. What I have here as well is that I have a Databricks Premium where I enabled the pass-through, meaning that I don't have to provide the app ID, app key, and tenant ID. If you are within your standard cluster, then you need to ensure that whenever you call the methods, you pass the app ID, the app key, and the tenant ID. So first thing that I'm doing here is to provide my storage account name and the container. And what I will be doing within this notebook is selecting the details from my entity that I exported from Power Apps, selecting the details, the data from the entity that was exported from Power BI Dataflow, and create an extra entity specified within Databricks and combine everything together and export that to the data lake. So what I'm doing here is defining a new HR employee entity. So I'm simply creating a new data frame specifying the schema. Next, I want to write this data frame to the data lake as a new CDM entity. Now the data, the schema here is defined by Databricks. So you can see that I specify the schema. And so when I write to the data lake, it will take this schema. So I'm creating a new entity, a new personalized entity within my data lake. And how does this work? I need to specify the format cdm.microsoft.cdm. The storage, provide my storage account. The container, so where I want to store my manifest, and the name of my manifest. I give the name of my entity, and I say whether I want to save it in Parquet or in CSV. Now this is already a great addition because previously we could only store data using CSV. Save. Now if I come and look into my lake, you can see that I have this new entity that I just created, HR, and here I have a default manifest, the config.json, and then I have my employee information with my employee.cdm.json that specifies the schema of my my entity. So if we take a quick look, so this is the JSON from the Power Apps. This is the JSON model.json from Power BI. You can see that's the Power BI. You can see the details of the entity. And if we scroll all the way down, we can see how it is partitioning. So it will also still point to always to the latest available partition, where it is located, and where the schemas are exported. Now, as you can see, both these files contain a lot of metadata, which is very difficult to manage. But if we look at our manifest, it's much more neat, much more simple to read. We have the manifest name that is default that I set. It says how many entities I have. So one entity called contact, and where is the definition of that entity, and the partition patterns. Now, currently, this is pointing to these existing partitions, but I also have the ability to specify other partitions or even apply wildcards to select more than one partition. And then if I look at the definition of my contact.cdm, I still have here all the details of my contact details. So I can see the details from my the name, the type, all of those definitions, and it's a much more simple way to manage these files. So going back to Databricks, I now want to read my CDM entity. You can see that it's reading the entity that I just wrote. I read the Power Apps contact. You can see that this has the ability to read the model.json. I read the Power BI data flow. Again, see that this time I'm passing the manifest, the path to the model.json, while here I pass to the manifest. I have a function that will union two data frames. I restructure my employee, saying that my employee will be called contact ID, first name, and then I will be adding 3 new columns to my entity. So first, I start by unioning my customer information from Power Apps with my contact information from Power BI data flow, and say which columns I want to select. And we can see that I have 341 columns. And now when I join and then expand with my employee data frame and my employee CDM entity that I created, I can see that I have a few more columns that did not match. So I expanded the definition of my my CDM entity, and then I can simply say create this as a new entity within the data lake. So if I come to the data lake, I have my new entity called Databricks entity that contains the details from the 3 different places. So from Power Apps, from Power BI, and from the Databricks entity that I just created. Now, I'm aware of the time, and sorry if this looked a bit rushed. If you need and you would like to have a better understanding of these 3 approaches, you can come to Adatis blogs and search for the Common Data Model series, where I talk in more detail about these different options. So thank you very much for attending. I hope you enjoyed the session, and if you have any questions, please let me know.